talk about the coefficients of correlation and determination. And this is the last video that we're going to do, and these are two important ideas. The first one is what we call R, and R is the correlation coefficient. And R squared is the coefficient of determination. And I'm not going to write all that out. But really, we shouldn't think of these necessarily as two different numbers. We should think of them as kind of two different ways of looking at the same number, because they in fact are the same number. It's just the second one is squared version of the first number. So if, for example, you get R squared, as most of you did in the first problem, equal to 0.9312, it's very easy to come up with R. You just take the square root of that number, and you can use whatever your favorite calculator is to type in the square root of 0.9312 and get 0.965. And so these two numbers really, they're completely connected to each other. Just one is the squared version of the other one. Okay, but what I want to do is spend just a little bit of time actually thinking about what R is in particular, and then we'll talk a little bit about what R squared is as well. But R is a number that runs from -1 to +1 with, of course, 0 right in the middle. Well, what is this -1 and +1 or 0? What do these numbers tell us about R? Well, -1 would mean that when we put our dots on our graph, it would mean that we get a picture where our dots are really very close to a straight line. If they're -1 exactly, then that means it's a perfect straight line. But if they're close to -1, it just means they're kind of close to a negatively sloped straight line. You'll notice that, You'll notice that for the example we did in class, we got -9, which means we had a pretty strong negative tendency there. If I were to draw this line through the middle, you would notice that the dots are all really close to that line. If I come over here to +1, I would get something that's really similar. The only difference is my dots would be going upward. And so again, I would get a line that's kind of right in the middle of them. And it's really close to a straight line. If it's exactly +1, then it's a perfect line. But if it's just like 0.99, 0.98, then you're getting something that's very, very close to a line. Now, when we get things in the middle, then all of a sudden you have graphs where the dots don't have much of a pattern at all. So it might be something like that, where the dots are just kind of somewhat randomly placed in there. And if you were to put a line, the best thing they could do is just make some sort of vertical line that splits them in half. But there's really no trend, no pattern, no relationship between these things. Well, what happens if you're somewhere in the middle? What happens if you're like 0.5 or something? Well, if you're at 0.5, you've got a little bit of both. So you've got a little bit of downward trend, but you got a downward trend, but the dots are still pretty scattered. So when I draw that line through the middle, you'll notice that there are a bunch of dots that are quite a ways away from it. So these dots down here are quite a ways below, and these are quite a ways above. But there is still some sort of noticeable trend going on. The same thing here. We would have some sort of noticeable positive trend going on. But the trend wouldn't be nice and tight like this one. So the closer you get to 1, the closer it is to forming a straight line, and the closer you get to 0, the closer you get to kind of jumbledness. So this is the correlation coefficient. You can see why this would be really, really useful. So if someone gives you data and they said, I've got a 0.9 correlation, then that means you've got a picture that looks pretty line-like. But if someone says, I've got a 0.1 correlation, then that means it's pretty jumbled. It doesn't have a lot of trend going on. Now we also have R squared. And one way to think about R squared is it's often people use R squared to kind of interpret how much of the trend can be accounted towards this relationship between the variables. So for example, R squared was 0.965, which you can of course translate that to 96.5%. And what that means is, if I want to figure out where one of the dots are on my graph, well, how some of that can be determined by looking at this yellow line, and some of it is randomness from the dot. Well, this 96.5% means 96.5% of the variance is due to the yellow line, due to the correlation, and only what's left, which what's left of that is 3.5%, and only 3.5% is due to randomness. If, however, we got a picture like one of these where it was, much lower, you might have 60% explained by the line and then 40% due to randomness jumping around. So the closer this is to 1, that means the better the line is doing explaining your graph. And people kind of use this in a quantitative way to describe things. Okay, what I want you all to do is I want you to look at this exercise and really all 4 of them, and then take just a moment and ask yourself, hey, and just ask yourself, can I guess what R is? Is R positive? Is it negative? Is it close to 1? Is it close to -1? So R equals what? So now's a good time. Pause your screen and go try it and see if you can be successful. Okay. Well, hopefully you did that. Now, as I look at this problem and I want to figure out what R is, if I look at this problem and I want to figure out what R is, well, what I would notice is that my trend is definitely downward, so I'm going to notice R is negative. So whatever I get from my R is a negative number. And is it pretty line-like? And I would say, yeah, it is pretty line-like. So I'm going to say it's negative. And so I'm just going to say close to -1 because it's pretty tight. So if you picked any number like 0.9, 0.95, anywhere around there, would be a pretty good estimate. 0.9 or 0.95. In anything negative and close to 1 does a good job on this problem. Well, as I look at this one, what's going on? Well, I have my R, but notice this is just kind of that jumbled mess problem, and I don't really see any sort of trend going on at all. And so this one is R0. It may not be exactly 0, maybe 0.1, -0.1, but it's definitely not really close to 1 or close to -1. As I look at this one, what do I notice? I notice a positive trend. So this means R is positive. And not only is it positive, but it also seems like it's pretty line-like, right? It's pretty close to the line. So I'm going to say it's close to +1. So when I pick my R value, when you go pick an R value, something like positive 0.95 or positive 0.9 or something like that's pretty reasonable. Now, as I look at this one's also positive because you can definitely see the lines are going up, but there's a lot more variance. So you'll notice they're a lot further from the yellow line than this last one was. So if I go to the one I had just a second ago, you'll see that they're actually very close to the line. And so this one, they're all much further away. So this one's definitely positive, but it's further from +1 than the last one. So if you picked 0.9 for the last one, you're going to want to pick a number a little bit smaller than 0.9. So I might pick something like 0.7 or 0.8 or something like that. Any of those are reasonable guesses. But it's going to be smaller than the last number. So that's an important relationship. All right. So that brings us to the end. And as you do the homework, I want to make a few observations. 11.2, we're going to keep 11.2 the exact same, so we're not going to make any changes in that. 11.5, the first half, this is exactly what we had in our notes, but this half, the second half, have been changed a little bit. You only have to do those 2 problems. You can skip the rest of the problems if you like. Good luck. Definitely come see me in my office hours. This is the last video, so what you can expect is a take-home quiz over some of this material in the last few sections, and then a final exam. So I want you to come see me, and I want you to be successful and make it through the semester. So good luck and congratulations.